Hi, welcome back to Teacher Think. In this one, I will be talking about implicit differentiation, part 3. If you have seen my previous videos under differentiating an implicit function, part 1 and 2, you will see that I wrote down some basic steps that I was using to guide you to get the concept. I don't have it here, so I think we can go straight forward this time. Now we have a function here, sin x plus y plus 3xy minus 3 pi squared over 4 equal to 0. So how do we go about this? Now, before I begin, please subscribe to this page. Hit on the notification button if you want further updates. Support this work by just subscribing. And this is Daniel. Let's see what we have today. So, in implicit differentiation, the first thing you need to know is that you apply derivative at both sides. We differentiate both sides of the equation. On the right side, we have 0, and then on the left side, we have all the functions there. So we apply derivative at both sides of the equation by saying that dx, because I'm taking derivative of everything here, I'll put it in brackets. So I have sin x plus y plus 3xy minus 3 pi squared over 4, giving me the derivative of 0. Okay, then because I want you to get the concept very well, usually I take you through step by step, basic principle steps that will make you get the concept. So my next step is use this derivative function to multiply each term one by one. So this is giving us dx. The dx here is telling us that we are differentiating the function with respect to x. So dx of sin x plus y, close the bracket, plus the same ddx of 3xy, then minus ddx of 3 pi squared over 4, then equal to dx of 0. In your next step, we differentiate each term one by one. Now, before I tackle this one, let me show you how to differentiate something of this form. Most of you are already aware. When you have something like sin 3x, the differential of this will give you 3 cos 3x. Most of you are aware. How do we do it? You first differentiate what you have in the bracket. When you differentiate 3x, the result is 3. Use it to multiply the differential of sine. When you differentiate sine, the result is cos. So cos what? The same what? 3x we have here. So this result is what? 3 cos 3x. You can use chain rule to arrive at the same answer. Okay, now looking at what we have here, we have sin x plus y. So we first differentiate this bracket. By differentiating x, when we are done, we differentiate y. We write down the result, then we use it to multiply the differential of the sine function. Do you get that? I hope you did. So applying that same principle here, first, I'll differentiate x, hold on, and differentiate y. Okay? Now, because I have an x term here and y, when I differentiate this x, the result is 1. When I differentiate this y, the result is 1. But I'm not going to write 1 because in implicit differentiation, the only rule, the only different thing you need to know is that any function that you differentiate, you have to indicate it. Any function in terms of its variable, you need to indicate it. So here we will differentiate x with respect to this dx. So we have to write it down, dx. So when we apply what I just said, when you differentiate this result, you have 1. Let me put it here. Now we differentiated x with respect to dx. So we indicated dx over dx. Okay? Plus, there's plus here. We differentiate this y. The result is 1, but I differentiated y term with respect to dx, so the result is still dy dx times the 1. I don't need to put it again. This one I was just using it to explain. Put this in bracket and use it to multiply the differential of the sine function. If you differentiate sine, the result is cos. Cos what? The same thing you have in that bracket, x plus y. As simple as that. So this is just telling you that use this to multiply the x. You get the s dx. use this to multiply the y, you get dy dx. Very simple. Okay, so we move on to this side. Plus, now watch carefully, we have a product function here, x term multiplying a y term. And because I said that we are treating these variables as two products, the first one is x and the second one is y. These three, we don't treat it as a product. It's a constant that you need to factorize out. So I'll bring it outside and bring a square bracket. Okay. Now, because this is a product function, we will use product rule, or what we call the sum rule. Or is that not it? Yes, the sum rule. So you first hold the first variable, or any of them that you want. Let me hold x first, maintain x, then differentiate y. When you differentiate y, the result is 1. But you differentiated a y term with respect to x, so 1 times dy dx. Or just say that use d ds to multiply y. So x dy dx. Then plus, product rule says you have to add the result. So plus, come back and hold the second variable, y, and differentiate the first function, which is x. When you differentiate x, the result is 1. Okay? Then you differentiated an x term with respect to dx. So you have to indicate it, dx, dx. So we write it here, dx, dx. Don't forget that this and this will cancel, giving us 1. Okay? For explanation's sake, I'm writing it. You don't need to indicate these things. Alright, so that is what we call product rule. So product rule says hold the first function, differentiate the second one, hold the second function, differentiate the first one. Or hold the second, differentiate the first, and so forth. Because multiplication is commutative. Alright, then we move on to minus. Now, assuming that the pi here is 180, when we fix it inside this function, this gives us a number. When we divide by 4, we get a constant. Okay? Now, what is the differential of a constant? 0. So you don't need to worry about this. This side is just 0. Equal to the differential of what? 0 is also 0. Okay? So the next thing we need to do is to know that this and this will cancel, giving us 1. 1 times 1 is 1. Plus, this and this cannot cancel. So we still have our dy dx. Put this in brackets, multiplying cos x plus y. Plus, now this can multiply this. This is the time you use your what? Constant. Now use your constant to open bracket. So 3 times this, we have 3x dy dx. Then this will cancel this, giving us 1. 3 times y will give us plus 3y. Okay, minus 0 is not necessary, so equal to 0. Now we can expand the bracket by using this to multiply that. So 1 times this, we have cos x plus y. Then this time this, we have plus cos x plus y dy dx plus 3x dy dx plus 3y equal to 0. Now, the next step is group all functions containing dy dx to the left-hand side of the equation. So I have one here, I have another one here. So let's start with this one. So we have cos x plus y dy dx plus this side 3x dy dx. Then we can write this function plus cos x plus y plus this one 3y equal to 0. Now because we have a common term here, dy ds, we can factorize it out. So once you factorize that, you have cos x plus y plus 3x into bracket dy dx. Okay, so this time this we have that, this time this we have this, plus cos x plus y plus 3y equal to 0. You can leave your answer here, we are done. Or if you want to continue further, you can take this to the right hand side of the equation and divide through by cos x plus y plus 3x to make dy dx the subject. That is a choice you need to make on your own. So we end it here. This is what we call implicit differentiation. So go through all the examples I have given you on implicit differentiation in this same playlist, Engineering Maths 1. I will see you in the next one.